and welcome everyone to this session on SQL Server and Kubernetes. A little bit about myself first. My name is Andrew Pruski. I'm a SQL Server DBA, originally from Swansea, Wales, but I've been living over in Dublin, Ireland now for about 7 years. My blog's there, DBA from the Cold, posted multiple articles about running SQL Server on Kubernetes, some of which I'm using to base this session on, and some of which go a little bit deeper. So if you want to check that out, you're more than welcome. And then my Twitter handle on the slide there as well, at DBA from the Cold. So if you have any questions after today, please feel free to reach out. I'm always willing to talk about this stuff. So on to the session. The aim of this session is to give you the background knowledge and some code so that you can go and start playing around with SQL Server running on Kubernetes for yourself. So we're going to talk a little bit about what Kubernetes is, a little bit of history about it, and then we're going to dive straight in and start running SQL Server locally on Docker Desktop running Kubernetes. So we'll just have a play around and see how we can get Kubernetes up and running. And then we'll delve into the different components of Kubernetes. So things like the master components, the worker node components, and how they all fit together. Then we'll have a look at using a declarative method for running SQL Server in Kubernetes. And then we'll have a look at persisting our data for SQL Server in Kubernetes. With SQL Server folks, data is kind of important, so we'll look at a way of retaining our data when we run SQL Server in Kubernetes. And then to wrap up the session, we'll have a little bit of fun. We're going to do some chaos engineering for SQL Server running on Kubernetes. But first things first, what is Kubernetes? Now, the definition there is from the kubernetes.io website, and it says that Kubernetes is an open source platform for managing and deploying containerized workloads. Great. What about Docker? Isn't Docker a platform for deploying and managed containerized workloads? What's the difference there? Well, with Docker, you install Docker on a host, and you run your containers there. What happens if that host goes down? It's a single point of failure. Kubernetes gives us the option of having a fleet of hosts where we can run our containers. And we don't typically say to Kubernetes, hey, I want to run a container there, I want to run a container there, I want to run a container on that host, I want to run a container on that host. We just throw our workload into Kubernetes and it sorts it out in the background for us. It is abstracting the infrastructure away from us. So that's a little bit of what it is, a little bit of the history behind it. It was originally developed in Google, and Kubernetes itself is a Greek word. It means helmsman or pilot. I always mention that because it explains the logo. While it was being developed at Google, its actual code name was 7 of 9 because it came from Google's Borg system. So 7 of 9, a friendlier Borg, and it also means why there's 7 spokes on that wheel there, apparently. So originally designed by Google, it's now hosted by the Cloud Native Computer Foundation, and version 1.0 was released in 2015. So coming up on 5 years old now. So compute terms still fairly new, but it's getting more and more mature as the years go on. So that's a little bit of what it is. That's a little bit of the history of it. But the main question I get when it comes to Kubernetes is why? Think about all the platforms we have for running SQL Server. We have SQL Server on physical machines, SQL Server on virtual machines, SQL Server up in the cloud with Azure SQL DB or Amazon's RDS. We even have managed instances. So why would I want to run SQL Server on Kubernetes? So let me tell you a story. A couple of jobs ago now, I was working with my QA department in my job, and they were having a problem refreshing their QA environment. Their QA environment consisted of a load of virtual machines that had the full production stack on them, each one meaning they wanted an instance of SQL Server. They were having problems wiping those machines and reinstalling SQL. So these were full-blown instances of SQL, so we decided to get rid of the full-blown instances of SQL and move them over to a host running Docker and run SQL in containers. And this worked an absolute treat. It went from around 40 to 60 minutes to refresh a VM to spinning up an instance of SQL Server fully configured with all of its databases ready to go in less than 2 minutes. Whichever way you look at that, that's a huge saving. So I sat down and I started thinking, whoa, I don't really like this idea of having to install SQL anymore. Can I run SQL Server in a Docker container in my production environment? And I sat down and I really thought about it. And the longer I thought about it, the answer was obvious. And that answer was no. We were finding certain issues with running SQL Server in a container that would have crimped the whole running in production. For instance, we're running on one Docker host. What happens if that host goes down? Okay, we did come in a couple of times in the morning, came down, that host had gone down, all the SQL instances on that host are down, QA can't do any work. Okay, we can bring the server up, we can spin the containers back up, we're good to go again, but still, there's no high availability there. We also found that when it gets to about, say, 40 or 50 containers, managing those containers is a little bit difficult. So is SQL up and running in those containers? Is it healthy and running? How do we check? If there is an issue with SQL running in those containers, are the containers going to automatically restart? If they do automatically restart, how are we going to persist our data? These are the problems that we were having that prevented us from using SQL Server in containers in production. So why learn Kubernetes? Kubernetes is an orchestrator, and orchestrators give us the tools to overcome these challenges. We can easily persist our data. We can run health checks against applications running in containers on our systems. And we have that built-in high availability with having multiple hosts where we can run our containers. So why learn Kubernetes? Kubernetes is the leading orchestrator out there at the moment. It is doing so well that competitors, say like Docker, who have their own orchestrator competitor in Docker Swarm, are incorporating it into their platform. It's quick and easy to deploy and maintain containers. Spinning up containers is very, very quick. We have high availability built in. And if you are looking at SQL Server 2019 big data clusters, Kubernetes is the technology built on top of that. Sorry, Kubernetes is a technology that big data clusters are built on top of. So if you're checking out those, I highly recommend you learn a little bit about Kubernetes. Okay, so let's get started with running SQL Server in Kubernetes. So we've got a few options if we want to run Kubernetes locally. We have Minikube. If you check out James Anderson's blog, Database Avenger, he's got a great article on how to get up and running with SQL Server in Minikube. We have Docker for Desktop. Docker have incorporated Kubernetes into their Docker for Desktop product. It is literally a checkbox, which we'll see in a demo. You check that box, wait until it pulls down all the relevant images. It takes about 10, 15 minutes, depending on your internet connection. And you have a one node cluster running on your laptop. We have micro K8s there as well. Another tool that you can use, really handy if you're running Linux desktop. I use it for my Fedora environment all the time. Runs as a snap, and I've got a one node cluster running really easily. And we have K3S, which is an offering from Rancher. Pretty much the same thing as a lightweight version of Kubernetes that if you want to run Kubernetes on a Raspberry Pi, highly recommend you check out K3S. Other tools I'll be using, so I'm going to be doing my demos, I'm going to be doing everything in Visual Studio Code. It's also got it's a great scripting environment. If you haven't checked it out, highly recommend you do. Got a great couple of plugins for Kubernetes and Docker as well, and we'll have a look at those. To connect to SQL, we could use Azure Data Studio or SQL Server Management Studio. And also we could use at the bottom there, the MS SQL CLI, which is a new command line tool from Microsoft that is cross-platform that we can use. It's like SQL command on steroids. I'd say it gives us some really, really cool features like IntelliSense, and the output of the commands is formatted nicely as well. And the second from last one there is kubectl, kubectl, however you want to pronounce it. kubectl, I call it kubectl. This is the main tool that we use to connect and manage deployments in our Kubernetes clusters. So let's go ahead and let's start looking at how to run SQL Server in Kubernetes locally on our machines. So I'm going to talk about a few things here. We'll cover the actual concepts and the components of Kubernetes, but I just want to show you how easy it is to get up and running with this technology. As I said, it's a simple checkbox with Docker for Desktop. Install Docker for Desktop, go to the settings, literally check that, hit apply and restart. After a certain while, you will get this little Kubernetes with a green icon next to it, showing you that you are running a one node cluster locally on your Windows 10 machine. So here we go. the first thing we need to do is get an image that we want to run in our Kubernetes cluster for SQL Server. Images were explained to me as the installed state of an application in a reusable format. They're baselines that we can use to build containers from. And each container built from an image will be a carbon copy of all the other containers built from that image. So we're always spinning SQL up from a known state. And so to get the SQL images that are available to us, we can use an invoke web request to that URL, hit execute, and then have a look at the content, and we get a list of all the tags of the images in that repository. And I'm going to use the SQL 2019 CU4 Ubuntu 1604 image, actually. There we go. So I've already pulled that down to my local machine, so we can check with Docker images. Oh, come on, Docker. There we go. And we've got it at the top there. So that's my 2019 CU4 image, and that's what I'm going to use to deploy SQL Server into my one node Kubernetes cluster locally. So just going to make sure I'm pointing at the right cluster. Excellent. And I can confirm that by kube control get nodes, and that'll show me all the nodes on my cluster. This is a one node cluster. There it is. And now I can run something called a pod in my Kubernetes cluster. And that should look fairly familiar to anyone who's ever spun up SQL in a Docker container. So instead of Docker run, we're saying kube control run, a deployment called SQL Server from an image, which is the 2019 CU4 image, accepting the end user license agreement, and then specifying our SA password. We can hit execute. And that's going to deploy SQL Server into my Kubernetes cluster. Again, a little warning there that the code I'm using is deprecated, but I wanted to show you this version because I wanted to get it as close to a Docker run statement as possible. Okay, let's have a look. I can view my deployment. Ready, up to date and available, all ones, so it's looking good. I can view something called a pod, SQL Server, up and running. And I can actually jump into that pod, like jumping into a Docker container, navigate to where SQL command is, connect to SQL, and then say, run a simple SQL query. So there we are, SQL Server 2019 running in Kubernetes on my local machine. But let's be honest, that's not good. That's not what I want to do. That's not great. I don't want to be execing into things and having to navigate to where SQL command is to run SQL statements. What I want to do is open this pod up so that I can connect to it, say via MS SQL CLI or Management Studio on my machine. I can work with SQL that way, exactly the same as we would as a normal SQL instance. So what I can do is something called expose my deployment. So I'm exposing this on port 1433 to port 1433, the default port that SQL listens on. So hit that, SQL is now exposed. And what this does is allow me to connect to SQL Server running in my Kubernetes cluster on localhost. So I could use the MS SQL CLI with localhost, my password, and run the same command we just did. And that should go on, hit my SQL instance, and there we go, it's come back. If I don't want to use the MS SQL CLI, I can jump into Management Studio, give that a refresh, and I've got my instance here. So that's the 2019 CU4 running in my Kubernetes cluster connected via Management Studio. And I'm just going to do a little bit of cleanup here. So great. That is how simple it is. There's literally two commands, one to run it, one to expose it, and then we can just connect into SQL Server as we would normally in Management Studio, Azure Data Studio, or with the command line tool. And we have that instance there, ready to go and available to us. Let's jump back into the slides. Yep.
Quick
I was about to say, is there any questions?
While you're just swapping. Yeah. What is the class of the system, memory, disk, and CPU that this is being run on?
Class of the system.
Yeah. So I'm assuming, to understand this correctly, you're running this on your laptop or your workstation or something like this, right?
Yes. So I'm running this in Docker Desktop, and this is all running in a virtual machine that's spun up by Docker Desktop. This is how we get Linux containers on Windows. So if we come here, it's CPU and everything is governed by the resources available here.
Mm-hmm.
If that answers the question. So this is going to change with Windows Subsystem for Linux 2 coming out, I believe, where Docker will no longer require that virtual machine, and it will use the Linux kernel that comes with WSL2 and run there. So you'll get a little bit of nicer features, like it'll spin up a little bit quicker, and we can use Docker commands in Windows Subsystem for Linux 2, which we can't at the moment with WSL1.
Fantastic.
Okay, cool. Okay, so that was deploying to a one-node cluster running locally on a laptop, but that isn't how Kubernetes works out in the wild. We will have a cluster with multiple nodes in it, and there are two different types of nodes, starting with the master node. The master node does exactly what it says on the tin. It controls all the components for managing the Kubernetes cluster itself, starting with the Kube API server. Everything in Kubernetes is represented by a RESTful resource. We call them the Kubernetes objects. They live in the cluster store, and each one of them has a unique HTTP path. Kube control makes requests to these HTTP paths to pull and retrieve information about the objects that live at those locations. So if I say kube control get pods, it's making a HTTP request to the URL where the cluster store is holding information about the pods on the system. I mentioned the cluster store. The most widely used technology is etcd, a distributed key value store. And what this does is store information about the objects that are running on the Kubernetes cluster. We have the kube scheduler. Now, this is what decides where our applications are deployed. So which nodes in the cluster do they get deployed to? And there's a whole bunch of algorithms in the background that work out how that gets done. But we'll see it pop up in a deployment later. Say, oh, kube scheduler is deploying to this node. We have the kube controller manager. This manages controllers within the cluster, and controllers are responsible for things for responding when a Kubernetes node goes down and making sure the correct number of pods are running in the system. And then finally, we have the cloud controller manager. This is what hooks the Kubernetes cluster into, if we're running in the cloud provider like Azure or AWS, Google, hooks it into the underlying cloud provider so the cluster can access resources in that cloud provider. And you can see things like when we spin up a load balance service in Azure, the cluster will say, hey, I need a load balance here, hits Azure and goes, please give me a load balancer for this service that the user has requested. So it just hooks in to the underlying cloud provider. So that's our master controlling our cluster. But we don't deploy any application workloads, that's the word I was looking for, to our master node. We deploy them to the worker nodes. And these are responsible for running and maintaining our pods. So we're starting off with the kubelet. The kubelet takes a pod spec from the API server and makes sure that all pods in that pod spec are up and running and are in a healthy state. We have the kube proxy. Now this enables service abstraction, and we'll cover services a little bit later, by maintaining networking rules and connection forwarding. And then finally, we have our container runtime. And in a lot of cases, this is Docker, or that can change, but this is what's spinning our containers up in the background. So we have our worker node. We have our master node controlling our cluster. We have our worker nodes where we run our pods. I keep saying that word. What's a pod? The way I think of it is, what's the Docker icon? It's a whale. What's a group of whales? It's a pod. A pod is a group of one or more containers that we run as the single smallest deployable unit of computing in a Kubernetes cluster. So we don't run containers directly, we run pods, and the containers run within those pods. And each container within a pod will share networking, same IP address and exposed on different ports, and storage. And they hold the specifications of the containers. So we have our master node, which is controlling our cluster. We have our worker nodes where we run our pods, and our pods are where we run our applications. Now, pods in Kubernetes are mortal. They die and are reborn. And when they die, they come up within the cluster with a different IP address. So that poses a problem for us. If we're connecting directly to the IP address and that pod dies and comes back up with a different one, we've lost our connection. This is where services come into play. Services provide a layer of abstraction over a group of one or more pods that provide a stable networking endpoint. So we don't connect directly to our pods, we connect to a service which maps our connection through to our pods. And there are different types of services. There is cluster IP. The pod gets an IP address that is only accessible within the cluster. Node port. The service is exposed on a different port, on a port on each of the nodes. So we can connect to each of the node's IP address and that port and access our service, which then routes our connection through to our pods. We have load balance. And I mentioned this earlier. If we request a load balance service in, say, Azure or AWS, it will spin up a load balancer for us in the background and provide us with an external IP that we can use to connect to our pods from outside of our cluster. And this manifests itself with Docker Desktop, as we saw, where by giving us a local host address that we can use to connect in. And then finally, we have external name. We can map our service to a DNS entry and reference that as well. So we have our master nodes controlling our cluster. We have our worker nodes where we deploy our pods, which inside run our applications. And we use our services to connect to applications in our pods. Okay, so in the first example, in the first demo, I used an imperative method to spin up SQL Server running in Kubernetes. I said to Kubernetes what I wanted it to do and how I wanted to do it. I said, kube control, run this with this image. But that's not the way we have to deploy to Kubernetes. We can use what's called a declarative method. And what that means is we can specify what we want to deploy in, say, a YAML file, and then just push that into Kubernetes and let Kubernetes work out what it needs to do in the background. So I don't say kube control run, I say kube control apply this file. Grab that file, work out what I've put in it, and deploy that into my Kubernetes cluster. So here is an example YAML file. So we start from the top. We have a, well, we have the API version, which is apps, because we're going to go with the deployment. Kind is basically type. This is a type of deployment, kind deployment. Then we go with some metadata. Give it a name of our deployment, SQL Server. And then we specify a number of replicas. Now, Kubernetes has this concept of desired state versus running state. We define our desired state in our code or YAML files here. And then when we deploy it into Kubernetes, it becomes our running state. And Kubernetes is constantly checking between the two to see if there are any differences. If the running state at any point no longer matches the desired state, Kubernetes will automatically fix that for us. So what I'm saying here with this number of replicas is at any one point, I want one pod running in this deployment. If anything happens to that pod, Kubernetes will automatically spin me up another one. So that's our replicas. Now we spec out the containers that we want to run in our pod. So I'm going to start off with name. I'm terrible at naming things, so I'm going to go with SQL Server 1. Then the image that I want to deploy from, and that's going to be the 2019 CU4 Ubuntu image. Then I'm opening up a port on that pod, port 1433, default port of SQL Server. And then I'm specifying some environment variables. So I've got my SA password there, and I'm accepting the end user license agreement. Always have to accept the end user license agreement when spinning SQL Server up in a container. And I fully admit, I've got my SA password there in clear text in a config file that maybe I'm going to push to something like a GitHub repo. So that's not great. And there's a little thing we can do with that, but for now, I'm going to leave it as clear text. So that is our deployment sorted. And remember, we're not going to connect directly to our pods, so we need to spin up a service as well. Scroll back. So, kind of service, type of service, and then some metadata, again, with a horrible naming convention, SQL Server service. And then we're specifying some ports. We have our port and our target port. What this is saying, if anything hits my service on port 1433, it will be routed through to the corresponding pod and hit that pod on port 1433. And therefore, I'll be able to connect to SQL Server. We have the selector. This is how we map our service to our pod. And then finally, we specify the type of service that we want. And for this one, I'm going to go for load balancer. Okay. So let's go ahead and let's use a declarative method to spin up SQL Server running in Kubernetes. Let's clear that one out and come down here. Excellent. Let's make sure I'm still in the same context. There we go. I'm just going to navigate to where all my YAML files are. Got a whole bunch of them here. Okay, let's have a look at that YAML file. So this is pretty much exactly the same as the one in the slides. So if we have a look here, I've got my type of deployment, my name, one replica, specifying my containers here, and then I've got my service spinning up here as well. So let's go ahead and let's deploy. Remember, we use a declarative method here. So I'm not saying to Kubernetes, run this, do that. I'm just saying apply -f from this file. Throw in that file into Kubernetes and letting it work out what it needs to do from what's in that file. I hit that. And there we go. We can see that my deployment is created and my service is created. So you can have a look and get deployments. There we go. Ready, up to date, and available. All ones. You can view the pods there as well. There's my pod running my SQL instance. I can get some more info on my pod by using the -o wide flag, so I can see things like the pod's IP address, what node it's running on. Okay, I haven't got much of a choice here because there's only one node, but can be handy. Oh, do that clear. And I could pull out a whole bunch of more information by describing my pods. Control describe pods. If we come down, it will show us the events that have happened to that pod as well, right at the bottom here. If I bring that up a bit, we can see the scheduler kicking in and saying, hey, I've successfully assigned this pod to this node. Okay, hasn't got much of a choice. It's a one node cluster, but that's the scheduler kicking in, which is on the master. Then we can see that kubelet is saying container image already present on this node. So I can start a container, create the container, and then start the container. So that's the one thing to watch out for. If you are spinning up, say, a new instance of SQL Server, say CU5 came out and I deployed this, I would have to wait while the Docker engine, the container runtime, pulls down that image and then spins up the container. So it wouldn't come up that fast. It's kind of a good idea to always pre-pull your images down. Say if you have a, say if you had a 2-node cluster, primary node fails, everything fails over to the secondary node, and that secondary node doesn't have your container image, you're going to have to wait till that image is pulled down until your pod can come back up. Okay, so let's have a look at the service. We deployed it as a load balance service, and that manifests itself with Docker Desktop as an external IP of localhost. And so I can connect in, same as before, using MS SQL CLI. There we go. We've got our version. Let's do something else. Let's create a database. Really simple. Create database, test database. Excellent stuff. Okay. And I can view that by doing select name from sys.databases. There's our database, and I can come back here, do a refresh. There's my database. Okay. Now then, let's grab those pod information again. And we can have a look at that IP address, 10.1.0.209. What I'm going to do now is I'm going to grab that pod name, and I'm going to say kube control delete pod. And what's happening here is I've deleted that pod. So the running state no longer matches the desired state. And Kubernetes should realize that and automatically spin me up a new pod. It has, and if I scroll up here, nope, never mind. It was 10.1.0.209. for the old pod, but now we have 10.1.0.210. The IP of the address has changed. We haven't got the same pod. We've got a brand new pod with a different IP address. So if I was connected via that, I'd have lost my connection. But thankfully, I have my service. And there it is. I can still connect in via localhost, so I won't have lost my connection. And I can come in and I can requery. I come here and do a refresh. I've lost my database. Now, the reason that has happened is because when I deleted that pod, Kubernetes went, hey, the running state no longer matches the desired state. I will spin you up a new pod, but I will spin it up from the 2019 CU4 image. That image has no knowledge of that database that I created because it was created after the last pod was spun up. So it spun me up the new pod, but I've lost those data changes. And when I say lost, I mean gone. There is absolutely no way you can get that information back, that data changes back, which for me as a DBA is kind of terrifying. So we need to look at a way of persisting our data from pod to pod within Kubernetes. So just a little bit of a cleanup here.
So while you're just cleaning up, there's a couple of questions coming to the queue.
Yes, of course.
I think potentially the way that your session's going, they may get answered ahead of the time.
Okay.
So first one, this is a simple demo with one node, one pod. Mm-hmm. How will SQL Server work on multiple nodes? What's the performance like? And is only one node, rather pod, ever active?
Yes, so you wouldn't spin up. So one of the beautiful things about Kubernetes is you can scale out deployments and have, say if I was running Nginx and I had 5 nodes in my cluster, I could run a pod of Nginx on each node and it would round robin connections through to each one of those pods. Mm-hmm. You can't do that with SQL Server because you can't shard your database out. So typically for a deployment with SQL Server, you would have one pod sitting behind one service because otherwise you're splitting your data across multiple ones.
So basically to do the scale out like that, there is no magic. You're going to have to do that yourself.
Kind of, or have a look at big data clusters.
Oh, but yes. Next one, how does replication of large amounts of data, terabytes of SQL Server data across HA nodes work inside Kubernetes?
HA nodes, as in, okay. So if you're running this in Azure Kubernetes service, you will, and we'll see in a demo soon, but I'm not going to use AKS for this, but you'd create persistent volumes, something called persistent volumes, and they would be attached to the nodes. If the node dies, those one of the controllers in AKS will detach those volumes and reattach them to a different node and then spin up your containers. The data will actually move across. Now, there are caveats with that. You need to set your deployment settings correctly to get those pods to move across as the node dies. And I've actually written a blog post about it recently if you want to go check it out. Bit of a plug. But yeah, it will actually move that data across for you.
Okay, so that's basically going to cover that question and the other two that are open. It's basically to deal with large amounts of data and how Kubernetes recovers from any one of these pods dying, which is basically, as you've said, you're going to separate the pod execution from the permanent storage of your SQL Server, which is, I'm guessing, coming up with your persisted volume, persisting data.
This is what's coming up, absolutely.
Okay, so I'll mark those questions as answered. If that's not the case and you still think that your question needs answering, please repose your question. Thank you.
Absolutely, yep. Just repose it and we'll come back to it at the end of this section. Fantastic.
Exactly.
Okay, so let's go through persisting our data for SQL Server in Kubernetes, because we have the same issue that we have with Kubernetes we have with Docker containers. If we don't use something to persist the SQL Server information, when we blow that container away, that pod away, it is gone. So we need something within Kubernetes to persist our data. And we start off with something called persistent volumes. These are just a piece of storage in the cluster. So it could be a little bit of storage on my local host here. It could be Azure file share up in AKS. It could be it's just a type of storage in the cluster that's lifecycle is independent of the pods that are running. So those pods can die, be reborn, be blown away, come back up. It doesn't matter. We still have our data. And the final point there is that we can provision persistent volumes either dynamically or statically. Statically means we are going and manually creating our volumes within, let's say, in Azure, available for our cluster. Or we can use a method to create them dynamically. And that's what I'm going to show you in the demos in a second. So those are persistent volumes, just a piece of storage in the cluster. The next concept is something called persistent volume claims. Now, this is a request for storage by a user. So someone like myself says, hey, I want some storage. This is where claims come in. So I request size and access type. So size could be 1 gig up to, I actually don't know the maximum limit, could be anything. And access type. So we've got things like read write once, only one node at any one time can write to that volume. Seems pretty good for SQL Server. We have read write many, where many nodes could write to those volumes. Probably not the best idea. Or read only many. That could be interesting for, say, if we have just, say, a large data warehouse that's completely read only and we want to stick some reporting over it, maybe we could use that. But the persistent volume claims are what's referenced by the pods. So they don't have any knowledge about the persistent volumes, because remember, we are abstracting the infrastructure away from us. And this is the way we do it with volumes up in Kubernetes in persistent data. So we have our volumes, we have our persistent volume claims, we have our pods. So I mentioned that we can create persistent volumes dynamically or statically. Statically means going off and creating them manually, which I don't really want to be doing. So let's do it dynamically. And the way we do that is by first defining something called a storage class. And this is exactly what it says on the tin. This is just a type of storage, class of storage, that is available to our cluster. So say we were running up in AKS. I'm using an API version of storage, VB1. I think I need to update that actually. Giving it a name, and then I'm setting my provisioner. This is the plugin here that allows me to hook into Azure and create persistent volumes of a type of Azure disk. And I'm going to the storage account type, standard local redundant storage, kind of managed. I want Azure to do the management for me. Okay, so we have our storage class that defines a class of storage in our cluster. We can then define a persistent volume claim. And so kind of persistent type, persistent volume claim, giving it a name. Access mode, I'm going to go with read write once. So only one node at any time can write to this volume. Storage class name is where I reference the storage class I just created. And then I define how much storage I want. Now I'm going to go with 1 gig here. I'm going to spin this up on the fly. If I went with 100 gig, we'd be sitting here for a while waiting for that 100 gig disk to be provisioned. So I'm going to go with 1 gig purely for demo purposes. But when I hit apply on this, in the background, it's dynamically going to create me my persistent volume, and we'll see that in a demo. But before we jump into the demo using persistent storage for SQL Server and Kubernetes, I mentioned that in my YAML file earlier, I had my SQL SA password in clear text in a config file, which it's not particularly great. So I want a way of getting rid of that out of my YAML file, and a way of doing that is something called a Kubernetes secret. So we create this secret, and then, so kube control create secret, and then we have from literal SA password testing 1122. That is our value. So it's going to be SA password testing 1122, and then we can reference that in our YAML file. So instead of having it in clear text, we say value from secret key ref, name MSQL, key SA password. So that's just one way of not having our SA passwords in our YAML files. Now there is a gotcha with this, and I will show you with it in the demos, but it's a lot better than have it in clear text, I think. So that's using the volume, that's using the secret. Let's now have a look at using the persistent volume claim. So I specify a volume mount here. I give it a name, and then I give it a mount path. And that var opt MSQL is where the default directory is for the SQL Server system databases. And it's by default the default location for the user databases in SQL on Linux as well. So I'm going to slide my persistent volume under that location. And then finally, I reference the name, my volume, and then my claim name, which is my MS SQL data. And that's what we created earlier in the slide. So we create our storage class, our persistent volume claim, and then we can reference it in our YAML file when we deploy SQL Server in. So let's go have a look. And let's have a look at persisting our data for SQL Server running in Kubernetes. Let's close that one out. And let's come into here. Make sure I'm using the right cluster. I'm in the right location. Oh, interesting. Yeah, all right. Okay, so the first thing I'm going to do, let's have a look at the storage class. Now, I'm not using AKS for this like I did in the slide, so it's going to be slightly different. Let's have a look at get content storage class. So really, really simple. I'm using, instead of the provisioner for Azure, I'm using the provisioner for docker.io.hostpath. So I'm going to call this storage class test SC using this provisioner. And that's all it is. So let's go ahead and let's create that. Fantastic. And then I can view my storage classes. Now, I didn't actually need to create that storage class. I could have referenced my default one, but I like to, the only reason I do is to show you the steps each through instead of just referencing something that's already there. So I could have used host path there, which is the default, but I'm going to use my custom storage class test SE, but they both use the same provisioner. So next thing first, let's have a look at our persistent volume claim. Now this is pretty much exactly the one in the slides, referencing my storage class name. I'm going to go with read write once and storage of 1 GB. So let's create my persistent volume claim. So again, not telling Kubernetes what to do is an imperative method. We're saying kube control apply and just work out what's in that file and create it for me. It's a declarative method of deploying into Kubernetes. Yeah, the persistent volume claim. There we go. We have our persistent volume claim. We have MS SQL data. We have a status of bound and its volume. So it's already gone and created a persistent volume for us and bound that persistent volume claim to it. Then I have my capacity, 1 gig, access mode of read write once, and my storage class. We can have a look at our persistent volume claim. So there, our persistent volume. We get PV. And there we go. We can see that's its name. Big long name like that because it's been created on the fly. Capacity, access modes match the claim. Reclaim policy of delete. You need to be a little bit careful with this. That's the default one. What that means is when I delete my persistent volume claim, it will also delete my persistent volume. There are other settings we can have here. We can have recycle, which will wipe the disk, or retain, which means if I delete my persistent volume claim, I still have that storage in the background, which is the one I'd recommend if you're using this with SQL Server. But this is a demo. I'm going to leave it as it is for now. I could do things like describe. Whoop. There we go. We can see where it actually is on the VM that it's running in. So this is actually running in the Docker VM, the Moby VM that runs behind the thing, and that's its location. So we can pull out a whole bunch of information there. And now let's create that secret as well. There we go. We get that secret. We can see type of opaque. I could try and be a little bit cute here and see if I can get at that value by describing it, but it's still coming through as opaque. But bring attention over here to the Kubernetes plugin for Visual Studio Code. I can come down here. I can go to configuration, secrets. And when it decides, I can go to MS SQL and my SA password, and boom. Secrets in Kubernetes by default are encoded. They are not encrypted. So even though they are a better way of hiding away your SA passwords, they are not as safe as you might think they are. So just be aware of that. Now, anyone with access can see that value. Okay, so let's close that. Let's go ahead and let's have a look at deploying SQL Server with our persistent volume claim. So we've got our service down here, and then we've we're mapping our secret, and then we have our volume mount there as well. So let's clear that. Let's jump up. And again, kube control apply. There we go. Nice and quick, we can see, get deployments, get our pods, and our service. There we go, localhost again. Come down here. And let's connect in, make sure I can connect and everything looks okay. So let's do an ATAP version, C4, excellent stuff. And let's create a database, same as we did in the last demo. So just saying create database, taking all the defaults, there we go. So let's confirm that's up there. Excellent. And let's come here and do a refresh. And there's our database. So back into Visual Studio Code. Get our pods. There is IP address of 10.1.0.211. And same as in the last demo, I'm now just going to grab that pod name and delete that pod. So again, Kubernetes should realize that the running state no longer matches the desired state and should automatically fix that for us. So we should be able to see that pod. There we go. We've got our pod up and running, age of 12 seconds, different IP address. But we still have our persistent volume claim and our volume. There we go. So hopefully we have our service, same as localhost. We should now still have our database. Boom. And there is our database. Let's do a refresh. There it is. Okay, so by using the persistent volume claim generated dynamically by using that storage class, we've been able to create a database, row the pod that was running SQL Server away. Kubernetes realized the running state no longer matched the desired state, spun us up a new pod with that persistent volume underneath it, and we have retained our database. Okay, so let's go ahead and let's do a bit of a cleanup. William, are there any questions?
Yes, there is.
Okay.
What's the licensing like for SQL Server on Kubernetes?
So last time I checked, Microsoft haven't officially released any licensing yet. So at the moment, I would recommend using the development edition. I know they've released, have they released? No, I'm not too sure. I can't go any further with that, I'm afraid. At the moment, I don't know if there's any licensing available for SQL Server on Kubernetes. Hopefully soon.
Another question just popped in. If you have to delete that pod, how will you do that? And actually, if we zoom in, I'm sure that's exactly what's right there.
Where it is. Yeah. So this is a little bit. So I can't type in demos at all. So if let's spin up. If I spin this up again very quickly, where are we? There we go. So the reason I have this bit of code here is what that bit of code does. If you do kube control get pods, and you say kube control delete pod, and then I come here and grab that, and that's how. See, this is why I don't type in demos. There we go, and that's how you kube control delete pod name. And what this little bit of code here does is grabs the pod name for me, so I can do that. Dropped in as a variable, and so I don't have to type in demos because I'm literally useless.
Fantastic.
Any others?
Nope.
All good.
That was everything so far.
No problem. Make sure I've deleted everything. Okay. Excellent stuff. Okay, so we've been playing around with declarative methods of deploying Kubernetes, SQL Server into Kubernetes. And this can get, you've already seen we've had our deployment file with our service in it. We've had a storage class deployment YAML file, storage class YAML file for our persistent volume claim. These YAML files can add up. So wouldn't it be nice if we had something that we could wrap all those YAML files into as a single deployable object? I think you can probably guess where I'm going with this. We do. It's called Helm. It is a package manager for Kubernetes. There is, similar to the Docker Hub, there is a Helm Hub in which we have charts, keeping with the nautical theme, that we can use to deploy applications that require a bunch of YAML files into Kubernetes. So we don't have to muck around with all these YAML files. We can just create a package, a chart, and use that to deploy. So I'm not going to mess around too much with that. I'm going to go straight in a demo and show you how this works. So coming down to deploying SQL Server via Helm, I'm going to confirm my Helm version. So it's executable that you install here. It recently went from version 2 to version 3. Version 2 used to have 2 components, the client side and a server side called Tiller. They've recently got rid of Tiller completely, mainly due to security concerns with it. It used to run with high amount of privileges on the cluster. So they've got rid of that completely. We now just have the Helm client that we can use. So what we could do is we can not do that. Do something like Helm search repo repository stable, which is like the Helm Hub, and we can have a look for MS SQL Linux, and it is up there. There we go, and we have a SQL Server 2019 Linux Helm chart. Now, it does say 2017 there. There is a parameter that you can use with Helm charts, and I think you can drop different images in. I haven't tried it with this one because I like to build my own charts, but we can do like a dry run on this, and we can have a look exactly what it is going to do. And we can see all this stuff here. And we have a look at a little bit more advanced. We've got all these environment variables. We got our service here. We got our persistent volume claim. So we can see exactly what it's going to do before we deploy it to our cluster. But as I said, I don't really want to use that. I'd like to deploy and build my own Helm repo. There we go. We got DBA from the cold one. It's just up in GitHub. And I can search for my 2019 CU4 chart up there. There we go. And all it is a, sorry, close this, GitHub repo with a bunch of charts in it. So I could do a test deployment from this. So same as before. There we go. This is a really simple one. So it's pretty much what we're seeing in the slides. We have our service, we have our secret, and we have our deployment with 2019 CU4-Ubuntu. So instead of having to deploy individual YAML files, so we create the secret, create the storage class, create the persistent volume, then deploy, we can bundle it all up and just deploy the one chart. So we can say Helm install SQL Server 2019 from my release. And that version .0.1.0 is the chart version that I've created. So there we go. That looks like it's deployed. It's told me what it's doing. I can come up and I can have a look. Helm list looks good. Get my deployments. Get my pods. And I've got my service as well. There we go. Exposed on localhost. It's a local band service. I could come in here. It's brand new deployment, so I've lost that database. But there we go. That's a nice, simple way of deploying applications to Kubernetes. Bundle it all up in one and just say Helm install instead of deploy, 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 deploy. So nice little handy feature. If you're looking at Kubernetes, I highly recommend you have a look at Helm as well. There we go. I can just delete that. So I can see we're coming up to top of the hour, and I've just got one more section to go. So I'm going to jump in. Any questions there, William?
There's no active questions right now, and you're also perfectly okay to slightly run over.
Awesome.
We have a full-on half hour. At 1:30 is when the next session will begin.
Ah, brilliant. Okay. So that's pretty much all I want to talk about with SQL Server, Kubernetes, Helm. What I want to talk about now is one of my favorite topics at the moment, and that is chaos engineering for SQL Server running on Kubernetes. What chaos engineering is a way of experimenting upon a system to see if it reacts the way we expect it to when it encounters failures. So what we're doing here is we're running things to say, okay, Kubernetes has this high availability built in. When I delete a pod, it should spin me up a new one. The running state no longer matches the desired state. So Kubernetes goes in. So we want to test that. And we have been testing that. We can just do delete pod and watch it spin back up. But it's a little bit dry. What if we had a nice GUI to test this chaos engineering experiment with? If we could test SQL Server's high availability on Kubernetes with a nice web GUI. And what if that web GUI was Space Invaders? This is a project I found on GitHub. It's called KubeInvaders. I will post a link to it at the end. And this is doing pretty much what you think it is. The invaders are our pods, and we play the spaceship. And when we blow the invader away, it actually kills the pod in the background. And we can test the high availability of Kubernetes by playing Space Invaders. It's probably one of my favorite repos ever, if not my favorite repo. So let's go ahead and let's play Space Invaders with Kubernetes. Nope, I've lost my demos. There we go. Now I'm going to switch to my cluster up in AKS for this. There we go. And what I'm going to do here is I'm going to run, just not using a declarative method for this, I'm going to run a deployment with 10 replicas. So I want 10 instances of SQL Server running for this deployment. I typically wouldn't do this, but we're playing a game. So, and we can have a look at that. Make sure those are running. And I've got my 10 pods. So I can grab this, come over here, drop that in. And now I can play the game. So, oh, I need to refresh this. And now I can play the game. Okay. And on the left there, while I'm killing the pods, you can see that Kubernetes is realizing that the running state no longer matches the desired state and is spinning me up new pods. And then the graphic screen refreshes as it goes. So we can see I've now got 9 pods running. Hopefully that'll flick up. Now I've got 10, 3 are still terminating. I can stick this into automatic mode as well and let the game play itself while I investigate my cluster and see what's happening in the background. So this is just a little bit of a fun way to play around and test the high availability of applications running on Kubernetes. And that'll go to eventually we'll start killing them because applications don't like being killed and restarted, killed and restarted, killed and restarted over and over and over and over, but it will take some time. That's a really fun way of demonstrating high availability on Kubernetes. So I'm actually going to stop that because that will just keep going. There we go. So come back here, delete the deployment. There we go. I'm back to the slide. So that is pretty much it from me. I've got some resources for you here. The link there is a link to my slides where you can get everything in, and the link below, sorry, the link at the top is the link to my GitHub repo, and which contains all the code for the demos I've been doing. I've got code for running on Docker Desktop, Micro K8s, AK8s. The second link down is a link to my blog posts with a summary of all the posts I've written about Kubernetes and running SQL Server in Docker containers. And the final link there is to the KubeInvaders GitHub repo. If you want to play around, highly recommend you check that out. It's really good fun. Are there any further questions, William?
There's one final question in the question answer window. If anybody still has questions, they should put them in as soon as possible. And the question is, Kubernetes, is it a real alternative to Windows or Linux failover cluster instances? And as a follow-on to that, are there any pros and cons?
There are definitely pros. They're the built-in high availability is one. Con, still relatively new, especially when it comes to running things like SQL Server on it. So I'd say it's just another platform that we have to run SQL Server on. Same with anything that you have your pros, you have your negatives. I'd highly recommend. I love this technology, but in my company, we're doing a massive proof of concept at the moment because I'm not convinced it's right for us. And I will only be convinced it's right for us once it's past that proof of concept. So I don't want to shoehorn in technologies. I want to use them if they are the best option available. So if you are looking at stuff like this, definitely test to death to see what little foibles there are in that technology platform. But it's just another option that we have to run SQL Server.